Okay, guys. Um, Something that a number of you brought up, I think CB and then also Devin, maybe, and brought up that the directions for this problem number 3 or example number 3 said to simplify, and you're right. Um, so I definitely need to move. I need to multiply in that -1. So that would give me negative. Okay, ne negative 2x minus 3 over x plus 2, because simplify does mean to do all the operations, and my restrictions are right here. Okay? All right, let's look at this last one here. Now, this one, example number 4, says solve ax minus a squared equals bx minus b squared for x. And what that means is I want an equation at the end that has x on one side and everything else on the other. Okay? Which means that I need to get the x's together. So I'm going to subtract bx from both sides, and that's going to give me ax minus a squared minus bx is equal to negative b squared. Okay? But if I'm solving for x, I want to get rid of everything that doesn't have an x. So here I'm going to add a squared to both sides. Oh, I see where this is going. Okay? So that's then going to leave me ax minus bx is equal to a squared minus b squared. That's interesting. Okay, now I'm not done yet. Remember, if I'm solving for x, I have to get x by itself. Anybody have an idea what I want to do here to get x by itself? Kyle? No? No? That's not what I want to do first. Kyle's suggestion was to divide by a, but that, I mean, I still got a b with the x. Austin? Factor out the x. X is in both of these terms, so I'm going to take it and put it out front. I'm going to get x is equal to a minus b equals a squared minus b squared. Now, I know that all of you are thinking, wait a minute, that thing on the right, I'm going to have to do something with that because it really looks familiar. Okay, and that's true. I'm going to. But that's not what, I'm not there yet. What do I need to do next, Gordy?
You need to put the a minus b on the other side.
How do I get the a minus b on the other side?
You subtract it.
I'm going to divide by a minus b because it's being multiplied by the x. Okay, and that's the way I solve. I need to do the inverse operation. Okay, so now this factor cancels out, and I'm left with x is equal to a squared minus b squared over a minus b. Okay, now I've got x by itself, but I can simplify that fraction over there. What do you guys see that needs to happen over there? Jackson? I got a difference of 2 squares. So I'm going to factor the numerator. I've got a minus b, or a plus b, times a minus b all over a minus b. Now, what do I always do before I cancel out, Gordy? I look for, did you say the zebra? I kind of like that. Or did you say zero? Did you say zebra or zero? The zebro. My zebro. Okay, now, I need to give the restrictions. That's what we call it. I don't know how zebro got into it. But what we do is we'll take the denominator, the one factor in the denominator, and we say that a minus b cannot equal 0. So I'm going to add b to both sides, and that means that a cannot equal b. Because if it does, then I have 0 in the denominator. Okay, so my restriction is that a cannot equal b. But I can cancel these factors now, a minus b's. And I'm going to get that x is equal to a plus b such that, excuse me, such that a does not equal b. That means it equals, x equals a plus b all the time except if a equals b. Then it's undefined. Okay? And that's it. All right, good job, guys. You're ready for your homework.